Okay, in this lesson we're going to talk about solving quadratic equations by factoring. In order to talk about solving equations, let's first discuss the concept of an expression versus an equation. So, a quadratic expression is something of the form ax squared plus bx plus c. There's no equal sign in this, and in fact the only thing that you can do with something like this is to factor it. Or it can be simplified. Since there's no equal sign, no solving is possible. So you're not going to get this down to something that looks like, x equals 5 or, something of that nature. We contrast that with the concept of a quadratic equation, and the simple quadratic equation looks like ax squared plus bx plus c equals 0, or at least it could be written in that form. Now, the thing about this is there is an equal sign, so this is essentially two expressions set equal to one another. Your final result should have a variable by itself, so it will look like x equals 4, x equals negative 1/2, etc. So you'll have something solved for x in the end. So that's the difference between an expression versus an equation. So in this video, we're going to be working with equations. Now, before we get started, let's talk about what's called the zero factor property. The zero factor property is what allows us to solve quadratic equations by factoring. The property is that if a times b is equal to 0, then either a equals 0, b equals 0, or both. So it's a pretty straightforward concept. If you know that two numbers multiply together, product is 0, you know that one of those numbers had to be 0. Now, the thing you have to make sure you understand is that it does not apply to any other values. So for instance, if a times b is equal to 6, well, we can't really draw any straightforward conclusions there. I mean, a could equal 1 and b could equal 6. Those are two numbers that multiply to 6. That could also say a is equal to 6 and b is equal to 1. Those are two numbers that multiply to 6. But there's others. A could be 2 and b could be 3. If you multiply those together, the product is 6. Or if it's 3 and 2, that's fine as well. Or a could equal negative 1/2 and b could equal negative 12. Negative 1/2 times negative 12 is positive 6. There's an infinite number of possibilities. The zero factor only applies when your products equal 0. That's important to understand, and I'll explain that further when we do some examples. So let's get started in solving some quadratic equations. So the first example, let's try to solve x squared minus 2x minus 8 equals 0. Now, the process of solving here requires factoring. So that's why I say if you're not comfortable with factoring, go back to the last video and review that. But basically, in this case, the leading term coefficient is 1. So all I'm looking for are two numbers that multiply to negative 8 and then add up to negative 2. So 4 and 2 multiply to 8, but I need them to be negative, so let's do negative 4 and 2. That way they multiply to negative 8, add to negative 2. So this factors into x minus 4 and x plus 2. Now, let's think about this. X minus 4, this right here this is just a single number. It just represents one value. And the reason I know that is if I plug in something for x, say like 3, 3 minus 4 results in one single number. X plus 2 is also just one single value. Now it's unknown what that value is, like with the x minus 4, but it is just one number, because if I plug in something for x, 3 plus 2, if I plug in x equals 3, for instance, results in 5, just one number. Which is important to understand, because I have basically two numbers, which, if multiplied together, their product is 0. And if two numbers multiplied together have a product of 0, that means either the first number is equal to 0, or the second number is equal to 0, or both. We just basically assume it's both because we don't know which one it actually is. And this leads to two solutions, which is important. So now we have two linear equations which solve generally fairly easy at this point. So in this case, I'll add 4 to both sides. So x equals 4. Over here, I'm going to subtract 2. So that x, that cancels, equals negative 2. So those are the solutions to this particular problem, x equals 4 and x equals 2. And when you're working with quadratics, you're almost always going to have two solutions here. This is different from linear equations where you only had one. And we can check that these are the correct solutions by just plugging these numbers right back in. So if I put x equals 4 back into the original equation, then I would have 4 squared minus 2 times 4 minus 8, which should equal 0. So let's see. This is going to be 16 minus 8 minus 8, which does in fact equal 0. So that checks out. If I plug in the other, so x equals negative 2, let's see if it works. So it would be negative 2 quantity squared minus 2 times negative 2 minus 8, and that should equal 0 as well. So this is going to be 4 plus 4 minus 8, which does equal 0. So these both work out. So in general, you're going to find that quadratics have two solutions. There's a couple of cases where there would only be one, but in general, there's going to be two. All right, so let's look at another example. Okay, so our next example, let's take y minus 4 times the quantity y plus 6 set equal to 0. Now, this right here, I bring this up because occasionally you'll see this in homework where you already have the factors. And if you already have the factors and it's set equal to 0, that's really important that this is set equal to 0. You can just take each factor, set them equal to 0 separately, and then solve each one. So if I add 4 to both sides here, I get positive 4 as one answer, and then if I subtract 6 from both sides, I get negative 6 as my other answer. So if it's factored and set to 0, then you don't need to do anything other than set your factors to 0. However, you'll run into, on occasion, a situation like this. So the quantity x plus 3 times the quantity 3x plus 5 equals 7. Now it is extremely tempting to do something like this, and I'm going to write this in red because it's all wrong, to try and set each one of these factors equal to 7 and solve. It doesn't work. The problem is you don't know that these are both equal to 7 because we don't have a 7 factor property. We only have a 0 factor property, which means that doesn't work. So what we have to do, unfortunately, is we have to go through and FOIL this set of parentheses out. So I'm going to take x times 3x, and that gives me 3x squared. And then I'm going to do x times 5, which would give me 5x. And then I will do 3 times 3x, which multiply and give me 9x. And lastly, I'll multiply 3 times 5. So I'm just going through the process of FOIL here. Now, the reason I did that is I can now bring this 7 over and combine it with the 15, which will leave me with 0 on the other side of the equation. So let's simplify some things. So I have 3x squared plus 14x plus 8 equals 0. Now, this is a polynomial that we need to factor. So the unfortunate thing of this process is we started with a factored polynomial, multiplied it out just so we could get this thing set equal to 0. Now we have to factor again. Well, the 3 is a prime number, so I'm just going to try and do guess and check here, because I know 3x and x are the only two things that will multiply and give me 3x squared. Now for 8, I could have the possibilities 1 and 8 or 8 and 1. Or I could have 2 and 4 or 4 and 2. And that's it. Those are my only possibilities. So let's see which ones work here. Well, if I try 1 and 8, then this would be 3x times 8 is 24, and x times 1 is 1, so that's not going to work. Okay, so those are out as possibilities. All right, well, that's okay. I've got others. If I try 8 and 1, well, 3x times 1 is 3, 8 times x, so that would give me 3x and 8x, which would give me 11x, which is close, but doesn't work. So those are out. All right, whoops, I meant to erase those. Oh well. So 2 and 4. So 3x and 4 gives me 12. 2 times x gives me 2x. Those would add to give me 14x. So these will work. So I need plus 2 and plus 4. All right, I'm going to erase my scratch work here. And these are all things that I expect you're doing in your head for these possibilities. I'm just writing them out just to be expressive so you see what I'm doing here. All right, so I have it factored. Now I'm going to set each one of these factors equal to 0 and solve the resulting linear equations. So here, if I subtract 2 from both sides, I have 3x equals negative 2. And then if I divide both sides by 3, that cancels and leaves me with x equals negative 2/3. And over here, if I subtract 4 from both sides, I get x equals negative 4. And those are my solutions. That's one of the more difficult problems when solving by factoring, because you have to FOIL the problem out first and then factor it back later. So let's look at another example that's a little bit easier. y squared minus 3y minus 12 equals 6. So this is similar. It's just, first off, it's not set equal to 0, so I need to make that happen by subtracting 6 from both sides. But at least I don't need to factor a polynomial out using the FOIL method to start with. So y squared minus 3y minus 18 equals 0. Another nice thing about this particular problem is my leading term coefficient is 1. So I'm only looking for numbers that multiply to the constant, negative 18, but then add up to the middle term, which is negative 3. So 6 and 3 look like good possibilities, and I want that 6 to be negative. So y minus 6 times y plus 3 equals 0. So y minus 6 equals 0, y plus 3 equals 0, so that y equals 6 or y equals negative 3. And those are the solutions there. Next up, 5x squared minus 2x equals 0. So this is a particular situation that doesn't require much by way of factoring because there's no constant term. In fact, the only thing you can do is pull out a greatest common factor of x. So both of these terms have a greatest common factor of x, and if I factor those out, it's going to look like x times 5x minus 2 equals 0. Now, quadratics will lead to two solutions, and there should be two solutions here. You can know that because the highest exponent is generally an indicator to the number of solutions you can expect in an equation. So you can expect there to be 2 here. But maybe it would be a little bit more recognizable as to what that first solution is if I express the equation this way. So x plus 0 times 5x minus 2 equals 0. So that when I take this one, if I set that equal to 0, I find that 0 itself is a solution. And then if I take the 5x minus 2 and set that to 0, I get 5x equals 2, or x equals 2/5. So that is what we need to do there. Just don't forget, when you have an x over here on the outside, that it leads to a solution, and that solution is just 0. That's important. All right. X squared plus 8x equals negative 15. All right, so only thing different here is that, again, it's not set equal to 0. The 0 factor property only applies when it's set to 0. So you just need to start off by bringing that term over. So add it to both sides so that it cancels and comes over. And now try and factor. All right, so 5 and 3 look like great possibilities. And those are, in fact, the factors. So these are the factors. The solutions occur when you set the factor equal to 0 and solve. So x equals negative 5, x equals negative 3. All right, one last example here. T squared plus 5t minus 35 equals 3t. Now the only way that this is different is instead of a constant on the right-hand side of the equation, I have 3 times t. But that's no problem because I can subtract that entire quantity over and it still cancels out to 0 on the right-hand side. So I have t squared plus 2t minus 35 equals 0. And if I try to factor, which this one will be an easy one because my leading term coefficient is 1, it looks like 5 and 7 are good possibilities. And if the 7 is positive, that will make them add to positive 2, multiply to negative 35. So that's great. So t minus 5 equals 0, and t plus 7 equals 0. So my solutions are positive 5 and negative 7. Those are the solutions to this problem. This lesson is about solving quadratics using advanced methods. All of our advanced methods begin with a rather simple property called the square root property, which states that if x squared is equal to m, then x is equal to the plus or minus square root of m. Let's do a quick proof here just so you can see how this works, and it'll give you a little more insight as to remembering that plus or minus, because that's really important. So if I start off with the equation x squared equals m, well, to solve this, one thing that I could do is move m to the other side of the equation and have it set equal to 0. Because just like when I am factoring a quadratic and trying to come up with its solutions, I get everything to one side, have it set equal to 0, factor, and so forth. Now, factoring this particular quadratic, the thing about this is the variable m, if I knew that it was a perfect square, I could use a difference of squares. But I don't know that this is a perfect square. However, that's okay in this case, because when I'm talking about solving quadratics through advanced methods, I'm now permitting these solutions to be irrational values, which involve a square root, or even complex numbers, or imaginary numbers, I should say, which would involve the variable I, the square root of negative 1. So it's perfectly okay that this is not necessarily a perfect square. I can still apply the difference of squares formula. I just have to write x plus the square root of m and x minus the square root of m. So now that I have it factored, I set each one of those factors equal to 0. And solve. So we get x equals the negative square root of m, and x equals the positive square root of m. And so that's where we get this right here. It's just a little bit of a short notation to express it as the positive or negative square root of m. So it means the two different solutions there. They're in conjugate pairs, that is. When you're working homework, depending on the problem, some problems have inside the toolbar a plus or minus symbol, and so you can write, the plus or minus answer. If it doesn't, then just write, the first solution, square root of m. The second solution, negative square root of m. So just watch for that in the homework. So let's work a couple of examples with the square root property. So first off, x squared equals 81. These are both perfect squares. This one's pretty straightforward. The answer here is just x equals plus or minus 9. You just have to make sure you remember that positive or negative, because there's two solutions for every quadratic. Remember, the degree tells you how many solutions you should have. One of them is positive 9, the other one is negative 9. Because if you take positive 9 and square it, you get 81. And if you take negative 9 and square it, you get 81. So there's two solutions here. All right, x squared equals 5. It's perfectly fine that this is not a perfect square. We can answer with irrational values, so just plus or minus the square root of 5. The next example, x squared equals negative 10. This is a negative number, and that's perfectly fine. we would take the square root of both sides, so x equals the plus or minus square root of 10, of negative 10. And since we have a negative underneath the square root, we just factor out the variable I, making it an imaginary number, which is perfectly fine here. So we're allowing for irrational and complex answers. Next here, x squared equals 45. So it would be plus or minus the square root of 45. Well, 45 is not a perfect square, but do remember that it can be simplified because it has a factor that's a perfect square. So 45 can be written as 9 times 5, which means this could be the plus or minus square root of 9 times 5. And when you take the square root of 9, you get 3 square root of 5. You always want to give the simplest form of your answer in the end. Last up here, this one looks a little bit different because I have a quantity x minus 6 that's squared and equal to 5. But this is okay. I would just take the square root of both sides. The square and the square root will cancel, so I will have x minus 6. That's a terrible 6. Equals the plus or minus square root of 5. And when you get your final answer, you want to get 6, or the x by itself. So I want to move the 6 over. So I'm going to add 6 to both sides. And when I do that, I just will express the answer as 6 plus or minus the square root of 5. Because I can't really combine the 6 and the 5 since the 5 is underneath the square root. And this example is important. You'll see why in just a little bit. But it kind of leads us into more advanced problems that we'll be able to solve. Now, mentioning again, if you're answering in the homework, if there is in your toolbox in the homework a plus or minus symbol, answer with a plus or minus. If there's not, answer with two solutions, one being 6 plus the square root of 5, and the other being 6 minus the square root of 5. So just write the two different conjugate pairs. All right, so the process of completing the square. This is one of the most important processes we have for dealing with quadratics. But you can write any quadratic in a form where the square root property applies using a process called completing the square. So the square root property, those problems were all fairly easy to solve. So if you can write all of those in a form that they're solvable by the square root property, that's a good thing. Let's delve into this a little bit and first look at where the name comes from and then look at the process for it. So the name comes from, well, let me tell you one thing. When you are working with algebra, whether you like it or not, there's something happening behind the scenes that's geometric. And when you're working in geometry, whether you like it or not, whether you see it or not, there's something happening geometric. So let's say, for instance, I am taking, well, let's just talk about squaring a number. So just any number. Let's say if I take like 5 squared. When I square something, geometrically, I can always interpret that as coming up with the area of a square. And similarly, if I multiply any two numbers, I can think of that as a length times width, and this could be the area of a rectangle. So this is area of a square, area of a rectangle. I can kind of geometrically represent these concepts in this sort of a way. So if I take any number and I square it, I'm getting the area of a square. So I've drawn a square here. When I multiply two numbers together, I'm getting the area of a rectangle. In this case, both sides of this square would be length x. One side of this rectangle would be b, and the other side would be x. And notice they match. I'll kind of set it up that way. Now, using this figure, let's say I manipulate it a little bit. let's say I decide I want to cut this in half and move them around. So, for instance, if I cut this in half, this might be that rectangle there, and then this one might be this down here. Notice this side length would be x, then that means this and this would be the distance x. But the other length here is b divided by 2 for each one of those, and I've kind of covered up my division symbol, but let me get rid of this stuff so you can see it. So this side length is x, that side length is x, these remaining rectangles are b divided by 2. Now, if I kind of push these over to where they line up, then what's going to happen is I'm going to end up with a figure like this. Okay? This little missing part right here, you could probably guess what the area is. But the thing about it is, if I knew what that part was, and I included it, I would have a complete square trinomial. So, again, this is x, this is also x, plus b over 2, plus b over 2. It's almost a perfect square, but it's not quite. It's missing that little tiny piece I've colored in blue. Each dimension of it is b divided by 2. If I square that number, that's what I would need to add to get a complete square. So this process here basically has shown me that if I take x squared plus b times x, and I add to it b divided by 2 quantity squared, then it will factor into, and I know that it's going to factor because this is a square where one side dimension is x plus b over 2, and the other side dimension is x plus b over 2. So it'll factor into that squared. Okay, so that's kind of all the images of what's going on. One last thing I want to mention is completing the square because of this value b divided by 2. It's going to work best when b is an even number so that you're less likely to run into fractions. Okay, let's go on to the next step here, which kind of illustrates a process. So to do the process of completing the square, take the constant in the equation, move it to the other side. Sounds a little bit strange because whenever we're solving quadratics, we want to get our quadratic set equal to 0. We're doing this in a different way, so that's fine. Divide both sides by the leading term coefficient. So if that leading term coefficient is not equal to 1, you do need to do this. You have to have that worked out, because if you have 3 numbers multiplied, you're working in cubes now. So we're not completing the cube, we're completing a square. So you have to make sure that's just an x squared, the leading term. You add b over 2 squared to both sides of the equation. Factor the resulting trinomial into x plus b over 2 quantity squared, and solve using the square root property. So these are generally the most important steps, and they're actually both very straightforward. And when you get down here, we saw how to solve problems using the square root property wasn't all that difficult. So as long as you get used to this and you practice this method, it can solve pretty advanced polynomials rather easily. So let's do some steps. Practice with steps 3 and 4 before we go forward, though. That's usually where students kind of get stuck. So we want to find the value of c such that the quadratic is a perfect squared quadratic and factor it. So for instance, if I have x minus 10x, x squared minus 10x plus c, then the value c is going to be b divided by 2 quantity squared, so negative 5 squared, or 25. So I want to do x squared minus 10x plus 25. That's the value. That's now a perfect square trinomial. This is going to factor into x minus 5 quantity squared. So it's just half of this number. Okay, so it's always factoring into x plus b over 2 quantity squared. I don't need to go through a factoring process, although I absolutely could. It's just I'm setting it up to do that it's going to work out easily. Let's see another one. All right, so what would I add here? So the constant value that I add here is going to be negative 14 over 2 squared. So 14 over 2 is 7. 7 squared is 49. So it would be y squared minus 14y plus 49. And this factors into, just take half of this b term. So y minus 7 quantity squared. Okay, a couple more quick examples here. This next one, if I take negative 5 divided by 2 and square it, remember when you're squaring a fraction, you square the numerator and denominator separately. So this is where I've said in the last slide that it's best when your b term is an even number because you won't get a fraction here. But even if that's the case, these steps here still aren't that bad because this is just going to become, you know, half of this value. So m minus 5 halves quantity squared. So these steps still aren't that bad. The other steps in the process might be more difficult because you're working with fractions, but not necessarily. Here, if I take negative 12 divided by 2 and square that, this would be negative 6. Negative 6 squared is 36. So x squared minus 12x plus 36. And this would factor into x minus 6 quantity squared. So just again, half of that b term. So it's always going to factor easily there. That's why we're setting it up the way we are. Now, solving some equations using completing the square. Let's do that. So x squared minus 4x plus 5 equals 0. Always try and factor these things. If it's going to factor, that's the easiest thing that's going to be able to solve it. But if factoring's getting you nowhere, then maybe it doesn't factor. Maybe it does, and you're just not coming up with the right numbers. So completing square will always work for you. So if you start the process off, it says to move the constant to the other side of the equation. Then divide both sides by the leading term coefficient, which in this case is already 1. We don't have to worry about that. Then add b over 2 squared to both sides. So if I take negative 4 divided by 2 and square it, it's 4. So I'm going to add 4 to both sides of the equation. So I do it to both sides to keep things balanced. This factors into x minus 2 quantity squared. That becomes negative 1. Now we finish this off using the square root property. So I take the square root of both sides. Don't forget the plus or minus. And now I add the 2 over, so 2 plus or minus square root of negative 1 is I. And we're finished. So even though this is a pretty advanced problem, it's not that bad through the process of completing the square. So another example, y squared minus 12y plus 26. So again, I've chosen ones that aren't going to factor. You normally would start there, seeing if you can factor it, but in this case, I know it's not going to factor. I'm going to need to find 12 divided by 2 squared, so that's 6 squared, or 36. And I'm going to add 36 to both sides. So this already factors into y minus 6 quantity squared. I don't need to put any work into that. This comes up to 10. if I take the square root of both sides, it's the plus or minus square root of 10, and then just add the 6 over. So y equals 6 plus or minus the square root of 10. All right, this next example, 7a squared minus 14a plus 63 is equal to 0. Now, if you'll notice, the leading term coefficient is 7 and not 1. So one thing that I am going to need to do is divide everything through by 7 and get that leading term coefficient 1. Now what's nice is I've kind of hand-picked this problem so that after I do that, I still don't have any fractions. If I did, there's another process that I would be going to, which we'll talk about in a second. So to solve this, I'm going to move the constant to the other side. And if I take negative 2 divided by 2 squared, it's going to be positive 1. So I'm going to add 1 to both sides. So this becomes a minus 1 quantity squared equals negative 8, or a minus 1 equals the plus or minus square root of negative 8. Now, if you'll recall, 8 could be written as 4 times 2. And even though 8 is not a perfect square itself, it has a factor that is. So before I move this 1 over, I'm going to simplify this square root a little bit. So the negative can come out as an I. Then I have 4 times 2. So this is going to be 2i, because when I pull the 4 out, it comes out as a square root, which is a 2. So 2i square root of 2. Okay, and always end up erasing too much. The last step is just add 1 to both sides. So a equals 1 plus or minus the 2i times the square root of 2. And if you needed to answer this in your homework, if you happen to have the plus or minus tool, that's great, use it. If not, your solutions would be 1 plus 2i square root of 2 and 1 minus 2i square root of 2. You can just write them out both that way. So last topic here, the quadratic formula. So if you apply the process of completing the square to the general quadratic, ax squared plus bx plus c equals 0, you will eventually arrive at what's known as the quadratic formula. So this is just a product of completing the square, so it's not really any different. The only issue is it looks like it's always going to be easier because it's just a formula you plug numbers into. However, as humans, we are worst at arithmetic, and this formula relies solely on arithmetic, so it's very prone to error. However, if completing the square results in a lot of work with fractions, this is probably a better choice. You need to practice both of them because there's times where one is better than the other. It's good to have them both available to you. So let's start with some examples. So 3x squared minus 6x plus 1 equals 0. I'm going to solve it first using completing the square. Now, the leading term coefficient is not equal to 1, so I need to divide everything through by 3 and make it equal to 1. So it would be x squared minus 2x plus 1/3 equals 0. 0 divided by anything is just 0. So I've got a fraction here. It's probably going to make this process a little bit more difficult, but let's just see what happens. So x squared minus 2x equals negative 1/3. If I take negative 2 divided by 1, it's 1. Square that. I'm adding 1 to both sides, and I'm just going to go ahead and change that into 3/3 over here because I need common denominators to combine. So this is x minus 1 quantity squared equals 2/3. And when I take the square root of both sides, the only issue is when I take the square root of that fraction, I've got a square root in the denominator. I need to rationalize that. So I multiply top and bottom by the square root of 3 to rationalize it. So x minus 1 equals the plus or minus square root of 6 over 3, or x equals 1 plus or minus root 6 over 3. Now, be careful in your homework. Sometimes they want you to write this as two separate values. Sometimes they want you to combine it into one. To combine into one, it's not that big a deal. Just change the 1 into 3 over 3 and write it 3 plus or minus square root of 6 divided by 3. So just basically getting a common denominator and combining. Either answer is fine for me, but just watch for the way the homework wants it. Now let's do it through complete the quadratic formula. So in the quadratic formula, 3x squared minus 6x plus 1 equals 0. A is equal to 3, B is equal to negative 6, and C is equal to 1. And it's important to identify what those values are, because if you don't, then you could possibly run into, forgetting a negative, and that's going to start you off on the wrong page. So the solution here is x equals the opposite of negative 6 plus or minus the quantity negative 6 squared minus 4 times 3 times 1, because it's b squared minus 4ac, all divided by 2 times a. So 6 plus or minus square root of 36 minus 12 all over 6. And the work here is not so intense. It's just there's a lot of simplification and a lot of room for error if you're not good with arithmetic, which, because you're human, it's probably a weak point for you. That's why we invented calculators. 24 could be expressed as 4 times 6, so I could do this as 2 square root of 6 divided by 6. And I'm not quite done, but I'm getting close. I could factor out a 2 from each of these in the numerator, which will cancel with the 6 in the denominator. And so I have my final answer, 3 plus or minus the square root of 6 divided by 3. So I get the same result either way. And that's important to understand. You will always get the same result if you do your operations correctly with completing the square or the quadratic formula. And they will both solve every single quadratic that you hand it. So you could default to just only using the quadratic formula for every single quadratic you ever have to work with. It's just that it takes a while, and sometimes the arithmetic is prone to error, and factoring is generally easier and faster. So that's why we have all these different methods. Let's do a couple more examples. 2x squared minus 3x minus 15 equals 5. We do need to have the problem set equal to 0, so I'm going to move that 5 over. 2x squared minus 3x minus 20 equals 0. It's not important for the leading term coefficient to be 1. We don't have to divide through by the 2. We just identify a is equal to 2, b is equal to negative 3, c is equal to negative 20. So when we apply the quadratic formula, which I'll go ahead and write it up here so you can reference it. We just start plugging in as we would. So this would be x equals the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. And we start simplifying. So 3 plus or minus the square root of 9. Let's see, 4 times 2 is 8. 8 times 20 would be 160. The negatives cancel, so plus 160 over 4. So this is 3 plus or minus square root of 169 over 4. And you may not know it, or you may. 169 is actually a perfect square. 169 is 13 squared. So what that means is that this could be written 3 plus or minus 13 over 4. Now, what's happened here is we end up with rational values as our answer, which means this original polynomial could have been factored. So we just didn't notice it, or maybe we're intimidated by factoring with such large values. 20 has a lot of different possibilities. That's okay. My point here is that this process will factor, give you the solutions to any quadratic. So this, however, you can't leave this as your final answer. You have to fully simplify it. So this means 3 plus 13 divided by 4, and 3 minus 13 divided by 4. So 3 plus 13 is 16 over 4. So 4 is one answer. And this would be negative 10 over 4, or negative 5 halves. So there's the simplest form of the final answer. So if you run into that case, you do have to continue on and get the rational values as answers. One last example here. 3x squared minus x plus 5 equals 0. So a is equal to 3, b is equal to negative 1, and c is equal to 5. And just so we have it to reference, here's the quadratic formula again. And this is an excellent choice to use the quadratic formula, because if I tried to use completing the square, when I divide through by this 3, I would get x squared minus 1/3 x plus 5/3. So I have a lot of fractions to work with. So quadratic formula would be great in this case, or the best choice, I guess I should say. So it's going to be negative b, so the opposite of negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, all over 2 times a, which is 3. So this becomes 1 plus or minus the square root of 1. 4 times 3 is 12. 12 times 5 is 60. So 1 minus 60 divided by 6. Or 1 plus or minus the square root of negative 59 over 6. And I believe 59 is a prime number. There's nothing really I can do to simplify that, except pull the negative out as I. And there is my final answer.